Right, so just on a note about the stud vector, one cool thing is that you can actually use it with OpenGL because it's guaranteed to be continuous memory. Yeah. Just sort of to pick up a bit. So here's like a general list that I also wanted you to sort of think about, which is, stop writing using namespace std. You guys should be, just don't. It sort of can create conflicts in the global namespace, and sometimes it confuses IntelliSense, etc. So just don't write using namespace std. At least not in headers or anything. Also, if you can, try to avoid raw pointers, or that's at least sort of the more modern view on what people are sort of encouraging you to do. Avoid the raw pointers. Don't use like new or delete. Preferably create stuff on the stack if you can, because that's awesome. And the reason that's awesome is because you can rely on the constructors and destructors, so you don't have to remember deleting stuff. The standard library, for instance, will actually do it for you. So vector is doing new and delete under the hood, but you don't have to care about that, and you know that once you are exiting a scope, stuff will be deleted for you. Also, go to cppreference.com. It is actually a really great resource once you learn how to read it, but it might take some time in the beginning, and you might have to test some different stuff. But it's pretty close to the standard. Also, use all these tools. Use the standard library, use the modern features, etc. Make your job easier. So then we're moving over to more OpenGL space, or typical mistakes. So these are some mistakes that we have done, which has caused us a lot of trouble, which has been like super simple mistakes if we had just known. Let's see, if we just comment out this. Here's actually one example of code that I wrote that for my first lab, which didn't work. Okay, so you guys now have learned about like creating programs and deleting them, right? Christopher?
We look at. We didn't use that this function directly, so
okay.
We didn't do it.
What have you done? Do you like create vertex, etc.?
Yeah, we used a kind of a helper function,
right.
A function to do it as of now. So we probably should inspect that more closely, but we want to get going. So yeah.
Well, I can.
But you can give some pointers already, because once we talk about it, that probably come back.
Yeah. So basically, that's OpenGL, it wants you to do you have to do a bit of manual memory allocation yourself. So for instance, you have to like create the shader program that you want to use, and you have to delete it, and at some place you have to actually set the state machine to use that program if you're switching between several shaders. So you create the program by saying like GL create the program, and then I have for brevity omitted the part where like we open the shader and compile it and link it. So obviously that happens in the rest of the function. It's not really important for this example. What I've done is that I've created a handle wrapper. So something that's like a shader handle wrapper. So I'll just send in a file path to this class, and it will read, from that file path, it will read shader files, and it will compile it and link it and create a shader program. Everyone sort of good with that? Yeah. And then in the destructor, I'll delete the program because I'm awesome. I don't create memory leaks on my graphics card. And obviously, I'll also need a way to like say that I want to use this program, so set the state to a using state. So I'll say, GL use program. I haven't actually set this up properly, so all those functions are basically just functions I created myself, which prints different stuff. Obviously, I want to create a class for this because I don't want to redo and remember all this stuff. So I've been told that that's a good thing to do. So I create a handle. I give it an empty regular constructor. I give it a constructor that takes the path. And the reason I give it the empty constructor is obviously because, as you were taught in, programming, you should put all your declarations at the top. So then you obviously need an empty constructor, otherwise stuff won't work. Obviously, no one here puts all their declarations at the top, right? No? Good. You've sort of gotten rid of that habit.
Sorry, what do you mean?
Putting all, like if I, basically, if I need an int I later in this main, I'll like create I up here. Does anyone, or I'll create all my objects up here. Does people still do that, or?
I mean, personally, I don't do it for like very local stuff. If I use it for iterating through stuff, or like I use it for a section, I'll just declare it down there.
Yeah.
But if I use something in the entire program, I'll have it on the top.
Yeah, good. Okay, so basically always, like that's another sort of C++ professionalism thingy. Put your declarations as close to users as possible. Don't like declare everything at the top or whatever, which is what I know you are taught in the programming courses. I know at least we were taught doing that. I mean, if you don't need any other reasons except readability, it also sort of troubles with efficiency because of constructors running when they don't need to, etc. So like put your variables as close to usage as possible. So yeah, but obviously I, in this case, haven't been taught how to do that, so I need to create an empty constructor. So here comes my super contrived program. I'll create my handle at the top, and then I'll either like if 1 is equal to 2, or yeah, in that case I'll read all my shaders from my path, and if that's not the case, then I'll read it from another path. And then I'll assign age, which is the handle to the shader, to whatever shader is found in that path. Everyone understanding that?
No.
No? Okay. So where did it fell off?
All of it. Sorry. Like with no. In the main function.
Yeah.
Yeah. Again.
So I create my handle, which is a handle to a shader, right? And then if for some arbitrary reason, so say like if I get some sort of input, I want to read it from my path, and if that's not the case, I want to read it from another path. So for instance, I don't know if you've learned to do this yet, but you can also like say if we get more than 2 input arguments, or sorry, more than 1 input argument, then we should read it from my path, and if we get less than that, we should read it from another path. So now everyone's on board on what's happening.
Yeah.
Right. Okay. So and then obviously I have this nice function which creates the handle for me, which does some arbitrary work. Before it actually returns the handle. Look, right? Because I'm for brevity, I'm not adding extra stuff here.
Yeah, but could you just mention what some arbitrary work?
For instance, I find the folder that the actual shader is in, so I go there. I'm just I have to do some sort of work before I can actually set up the handle. So I, for instance, read in all the files or whatever. So some arbitrary work. Which is why I need a function for this, obviously, which returns a handle. I return a handle from the create handles, and basically, and then after I've created the handle, I say age.use program, which means that load the shader into the actual OpenGL state machine. Okay, so there's a bug on this slide. And there's not a bug in any arbitrary stuff, it's a bug in the stuff that's written here.
But where are you actually calling create handle?
Oh, right, shit. Good point. Create handles. Now I'm calling it. So now there's a bug here.
One less bug.
Yeah, now there's one. Yeah, now there's a bug here. So yeah, is there anyone who won't take a gander on what the bug is? Or perhaps where it starts, where it sort of is invoked? Yeah.
Line 164, unexpected token, create handles. Why is there a line switch there?
That's not because that's my style.
Why? You declare a handle and then...
No, it should be like this, or you used to sing it like that.
Okay.
I can keep it like that. We can do that on main as well, just so there's no more confusion. Yeah. So no one here sort of has any idea. Right? No? So I've just now said that in the create program, I'll print out, we'll create a program with an ID, just like your GL create program function does. And then for the delete program call, the delete program prints, that one, that deleted that program with the value of 1. So is there now anyone who sees the problem? Do not? Yes?
I don't see the cause of the problem, but you're deleting the program with value 1 twice, but you only created 1.
Yeah. Yes? Jonas? Informative.
Is it because so you run the destructor inside create handles and in main also?
Almost. Basically, what happens is that we create the program, right? Which is why we get the create program with value 1 in here, and that's the actual shader value that we get back. So that's a program identifier. And then in here we say that we want to return a handle, and we're returning this by value. We're returning the handle by value, which invokes a copy constructor. Obviously, you all remember copy constructors from object-oriented programming. So we invoke the copy constructor, and we assign it to age. And as soon as we've done that, the copy that we had here, that copy handle object dies, in which it gets run its destructor, which deletes the program. And when I just go down here and say age.useProgram, boom, we're trying to use a program that doesn't exist anymore because we deleted it. Yes?
Yeah, because it's actually misleading, because you even if you send it by copy, you actually are handling a reference to the GPU shader. It should be treated as a pointer.
Yeah. You would see the same if you created your own string class or whatever. If I just say that I have a string class, and in that class I have a pointer to the string, and in the destructor I delete the string, and let's say that I want to copy this object into something else. If I, instead of allocating new memory and string copying the function or string copying the string, I just sort of okay, I'll just point to the same string as the first guy. Well, when the first guy sort of dies and his destructor is run, then he'll delete his string, which is also the same one that I'm pointing to, and suddenly I'm pointing to trash. And that sort of is the same in OpenGL. And this one, it's not necessarily easy to see this one unless you know a bit more about how stuff is working. There are different ways of fixing that one, and that is what I call RAI bites you. Which is RAI is it's a good thing most of the time, but in this case it's you fucked up. There are different solutions to this. You could create this as a pointer, either a raw pointer or a unique pointer, preferably a unique pointer, which you can read about in CPP reference. You could create init and destroy member functions, so that you won't actually do this in the constructor. Instead, you'll create an init method instead. which takes the path, etc. And then here it says like mhandle is equal to GL create program, and instead of doing anything in the constructor, you'll do like .init and .destroy instead. But then you're sort of back to doing your manual memory managing again. Yeah. So that's not really a good idea either. You can also do what we call a move constructor, which is a C++ 11 thing, where I can basically say that, so here we have a regular copy constructor. Anyone remember seeing that? It's okay to say no. Yeah, everyone ish? Okay, so it is possible at least. Like I can say that, my handle is equal to other dots handle. And then I can take a copy that way. But, this is actually the problem. The problem is that that constructor gets run, because now we're just copying stuff. A move constructor means that instead of just doing like mhandle is equal to other handle, I also say like other.mhandle is equal to, 0 or something. And then here I'll say if mhandle does not equal 0, then you actually destroy the program. So in this case, the destruction suddenly just becomes an if statement. So that's one way of, there's different way of fixing this. I don't really have time to go into move constructors, I think. So I'll just say, look it up if you need to.
Are you providing that code sample so people?
I can provide the full code sample of doing it with like a full move constructor, etc. Yes.
So move, it means
steal.
Yeah, and do not destroy.
No, it was.
If I have the references, do not destroy the existing references. So.
Yeah, but you have to be the one that you still have to specify in your constructor that you have. So in the move, basically take the other guy's resources and then set his to illegal values, and then check for illegal values in the destructor. That's the sort of short version, and then I'll provide the proper code sample for this. So yeah, so that's typical mistakes. Also, so that's the area bites you. The next one is the size of. Have they done any size of operation? So for vertex objects, etc.
Yeah, briefly, right? For loading the buffers or filling buffers.
Have you done like a speech on the importance of doing that in bytes?
No.
No. Okay. So. Let's say that I create, I create a vector of floats, or I guess it's GL float, right? Which is like my vertices, and then I assign them some vertices, so like 1.0, 0, 0, 0, 0, 0, or whatever, right? So I create that, and then I want to, like, what's the function called again? It's something like
GL.
Let's say it's named like GL load value or something. And it's like GL.
Bind buffer?
Yeah. Is it bind buffer for sending the values in as well?
Isn't it buffer data or something?
Yeah.
GL buffer data.
Yeah. So we do GL buffer data and then
pointer to
buffer ID, right?
GL array buffer.
Yeah, GL array buffer, and then some sort of buffer ID, I guess. Sorry, yeah, you get the point. But then we come to the part where we're actually supposed to send in the vertices, right? Which is where you guys send in the array. And then after sending in the array, you send in the count. Here's the typical mistake of saying vertices.data. By the way, that's the one you should use if you're using vector and OpenGL together, because .data returns the actual C pointer, which is the one that OpenGL expects. Yes?
So if you use .begin, it will break?
Not necessarily. Like, it can't function, but then you're sort of relying on the fact that iterators are pointers. It will function because it's continuous memory, but data is the one that sort of shows the correct intent.
Yeah.
Other people also do one that I found really horrible, which is doing that. But also calling first or front or whatever is also undefined behavior in the case where the vector is empty. So it's data that is the correct one. But yeah, so here's a bug. Because I say that, you know, I have the vertices.data, that's the array that I'm sending in, and we're obviously sending, you know, 3 of them, seeing as that's the one that exists in vertex. And the solution to that is then doing like size of GL floats. And I'll maximize it again because I'm not using the term anyway.
Times.
Yes, size times GL floats. Because otherwise, you know, if I'll just send 3, then OpenGL goes, okay, that's 3 bytes. However, the float in this case, I think the GL float is actually determined to be 4 bytes. So, you know, you should have 3 times 4 instead of 3. Yes?
Is there a way to get the what's inside a vector? Like if there is GL float from, like, can you find out what is in there after you have declared it? Because
yeah,
you are using it twice, and if you change it later at the first stage, then it will break the code.
You can do, in this case, you can do, now we're then back to like, like being sure that it actually isn't empty, but you can do size of like vector 0. And yeah, yeah. That should work. There might also be other more readable ways of getting that out. I don't have them in my head currently.
Maybe.
Yeah. Question?
Could you maybe like check the type, like compile time or something?
Well, technically we already know type at that point.
Yeah.
Or what do you mean?
I mean like template. Template is that. Never mind.
Well, you know, you could do like. Nah, I won't show it because it might be confusing. But yeah, this one, like, you probably won't send vertices that are empty into your OpenGL, so, you know, just don't do that. Yeah, so you could obviously create a template function for that, etc. But
yeah, because here it's actually a runtime. Size of is a runtime function, right?
no,
No.
no.
Okay.
Size of is a compile time function
Okay.
because it's the size of the object.
Cool.
And also size of and dot size is not the same thing. Size of in this case actually refers to like how many bytes is the GL float, while dot size is how many elements do we have.
Length.
Yeah, length.
Count.
Yeah. Yeah, so that's size of mistakes. This is because OpenGL takes void pointers, so you can do whatever you want with them, and it's up to you to actually make this shit work. Which is why you'll just end up with like some weird stuff that doesn't work on your graphics card. Yeah. The next one is I won't actually show that. I'll just show it, you know, down there. Because I mean, I remember me and a classmate actually spent 3 hours trying to find that last one the day before the exam, because we were creating our own framework. I don't know if they're allowed to do that for this course. So we had all what's it called in English again?
Labs? No.
Hjälpmedel. So like everything was allowed, seeing as we had a home exam.
Yeah.
Resources?
Yeah, all resources allowed, seeing as we had a home exam. So we showed up with a framework to our exam so that we, you know, had a cube running.
Don't tell them that stuff, you know. Come on.
Well, I would have told them outside of class anyway. So do that, everyone. And we were sitting the night before the exam. We were sitting, creating this framework, and suddenly my co-student's code doesn't work. And we don't understand why, because we've been sitting there, written exactly the same code, and we start debugging it. Everything is just black. So it actually gets to the point where I just say, okay, we've checked for all mistakes. We have no clue what it is. I'll just start in this file at the first line, and I'll read it, and you'll read yours aloud, and we'll check that it's like exactly the same. And we go through that, and after a while, like at file 13 or something, you know, I say like, yeah, and then you say, you say uniform 3FV. And then it says, yeah, uniform 3F. No, that's not the same. So it turned out that he had forgotten one letter in his uniform call, and that was apparently a letter to like some coloring or something, so everything just broke. So you know, this is perhaps one of the cases where be a bit careful about autocomplete for the guys who are doing this in Visual Studio, etc. Make sure that it actually types what you expect it to type. Yeah. And then, so to round up, general tips, I guess you have probably already seen some of this before. So, you know, your background should be a unique color that isn't black. I don't know if you've already like taught them this, but do gray backgrounds, because like, for instance, if there's a bug in your fragment shader, then your cube turns black, and finding a black cube on a black background, that's pretty hard. So set it to something unique, for instance, gray. Also, there is this awesome function that we were never actually told about, I think, which is called GL-GetError, which will actually return you an error code. So you can use that to check, you know, if you have like void functions that say like create program, and you don't know if, you know, it worked, then you can say GL-GetError, and it will return a flag, which then is a problem because you'll just like get an error code. So you'll also have to then create a function which is like GL-error toString, which takes that enum and converts it to a string so that you can actually read what it is. So these are, yeah, general tips from me and other people I talked to. Next is like hard code stuff first, then parameterize them. You know, don't try to make stuff super general necessarily. One of the things we found that was also pretty good was to have, this sort of goes to a more architectural view, is to create some sort of resource class. So create a renderer or something, and that class, it might even be like a global variable, or a singleton, which is a hacky global variable. Like create that and put all the resources inside that. So put all the shader programs, all the like vertex objects, etc. Because you don't actually need to duplicate that across all your game objects. So put it there, and instead hand out IDs. So that when I want to draw something, I can say, hey, I want to draw, you know, shader number 1 and vertex number 1 with color number 3 or whatever. Or color you can probably send in, but you know, try to find some way to like isolate the graphic stuff in a place where you don't have to repeat yourself all the time. Yeah, and then, you know, here are some resources that you should probably look into. So for books, there's a really awesome book that is called Game Programming Patterns, which is this one. And the best thing about it is it's actually free online from the author's page.
Cool.
This is a guy who used to work at EA. I think he was working with like architecture there, and now he works at Google, so he sort of knows what he's talking about. And it talks about different way of structuring your program, or like different patterns that, you know, is smart to look at. Especially, for example, the one I talked about with like sharing resources and putting that in a class, that can like quickly turn into a flyweight pattern. So then you can, you know, go and look at that pattern, which includes code examples and you know, examples of when you would actually like to use this. And however, the one thing I will say is this code is written for to be approachable from all languages, so it doesn't actually do like modern C++. This is more probably closer to what you guys learned from your other courses. So, you know, don't look at it for the code quality, but look at it for the patterns, etc. And it's so here it like shows you how you can model stuff, and it shows you, you know, in here, instead of having each tree having their own mesh, bark and leaves, etc. You just like create one class, which is the model, which has all that stuff, and then yeah, they point to it in this drawing, but it's better to use an index or something. Because that's it's also more efficient to do it that way. And you could look at stuff like the component pattern, which is also really interesting. The only thing that I should say about this is some of you might think that this is awesome. I'm going to do this everywhere, which is it's a really normal phase to go through. I also did that, so I picked up this book, and suddenly everything was a component with like 100,000 commands, which fueled into event queues, which, you know, all that stuff. And I came back to one of my earlier graphics assignments, and I was like, what the fuck is going on here? Because I would like overly abstract everything and try to make everything so, you know, high code quality, sort of. So because you quickly turn into the mindset that you have now learned the hammer, everything is a nail. So, and it's okay to go through that phase. Just, you know, be aware of it, that sometimes it's like, don't actually go for these patterns because they're adding complexity. So this might be relevant. You should look at them, but know that for you to really gain stuff from this, it's sort of like they add a lot of initial complexity. So unless your program is so complex that, you know, that you get to this point of initial complexity, then, you know, it's not necessarily worth adding. So be skeptical, but it's also a really great resource. There's also a book called A Tour of C++, which is written by Bjarne, so the guy who invented C++. It's a really short book. It's like this big, which I would recommend for people. It talks about C++ 11 and also 14, I think. And it's also pretty easy to read, and it takes like it's meant for people if you come from another language or old style C++. And then some videos. So, you know, modern, like, I'm not expecting everyone to read all of these or listen to all of this, because many of them are quite long, but, you know, you can go through them and look at different stuff. So we have the modern C++, what you need to know. That's held by Herb Sutter. And he basically talks about C++ as if you're coming from another language. So he takes, makes sort of like analogs to here, how this is the stuff that we have in Java, and here's how it looks in C++ now, or whatever. We also have the Mike Acton talk on data-oriented design from CPCon. That is basically the opposite to that one. Because this guy is like really, you know, just do what you gotta do, and don't abstract stuff. There's no reason to abstract yourself away from the machine necessarily, because that's inefficient, and your problem is that you're running on actual hardware, etc. So he's quite provocative in that video. There's a guy who talks about using the STL algorithms. So if you found the algorithms to be interesting, then that could be a video for you. The game engine using SB C++. So that's a guy from Blizzard who created a game engine using C++ 11 and talks about that. He also covered some of the topics that I thought I was going to cover, but that I saw I wouldn't have time to. And then this one, the last one, I actually recommend sort of everyone seeing, because that might actually help you. It might help you or it might confuse you. It's basically a guy from the C++ team at Facebook who goes through like the most common bugs that they see at Facebook when people are programming in C++. And a lot of them are stuff that you would probably also fall into. Like, I find bugs there that I've seen people, including myself, fall into. So, yeah. I think that is it.
Cool.
Or one more bug to add for the typical mistakes, because now that I've taught you vectors, someone will obviously do this one, because I've seen everyone do it. Do we have a pen?
Yep. There should be two over there. Yep.
So this is the sort of typical thing that everyone does when they learn about vector. So a vector is an array, right? Essentially, with a number of elements, which is heap allocated. So it's just like you would do it with like new and delete, or it's just as you would do it, just not naively, with new and delete, etc. And at some point, you guys have obviously been taught a lot about pointers, especially in the object-oriented course, and that everything is pointers. I'm sort of here to say, be a bit more careful with your pointers. If you can find something else, like indices, for instance, like an index, that's usually better, because one of you will make the mistake of finding out that, hey, I actually need, a pointer to this thing. So you'll create a pointer into something in the vector, and then later you will you'll say pushback, because obviously you need to add something else to your vector. Well, if the vector at that point sort of has reached its limits, it will allocate new memory, delete the old stuff, or first allocate new memory, copy the old stuff into the new place, delete the old place. So if I have a pointer in there and I add an extra element, then the vector will delete this stuff and create a new vector sort of over here instead, which is larger. And then you will try to use that pointer, and then your program will crash, hopefully. And also this is sort of like, I'm saying hopefully here because one thing that you should learn now, especially once that you guys perhaps start turning on like optimization, etc. So, for instance, running your program in release mode instead of debug, which some of you might actually go and do. In debug, this would probably give an error message. If you're doing this in release and sort of all the checking facility is off, then obviously C++ is doing whatever it can to do stuff as fast as possible. So, it sort of takes into, it sort of thinks that obviously you won't point into like random memory. So it won't check that for you, which means that when you actually run this program, it might be that if you're lucky, you'll crash, and you'll be told where you crashed, but probably you'll just like get a segmentation fault. If you're really unlucky, the sort of resources from the vector is still there. So your program will, continue to run perfectly well for perhaps a minute, and then you resize something else, or you need memory, so someone else will start reusing this memory. And suddenly, your calculations based on that pointer won't make any sense anymore. So you'll just start having like random behavior in your program. Yeah?
What did you say caused this, like, the deletion?
So if you have a vector, and it needs to, so I say I have a vector of 2 elements, and I say pushback, so I add a third one. That vector has only allocated place for 2, then it needs to allocate place for 3, because it has to be like a continuous memory, like an array. So it will then allocate space for 3 members, copy the 2 previous members into that array, add your third one, and then also delete the previous one, because otherwise it would leak. And if you're pointing into the vector, it won't like tell your pointer that. So you'll sort of get stale data.
But there's spare capacity in vectors, right? So
yeah. So vector always doubles the amount of memory you need.
Same as in Java. If you reach a capacity of 0.75, it doubles the size of the vector.
Yeah.
So, yeah.
Which also means that we can do that before it sort of reaches the limits, maybe. So
exactly.
Yeah.
So if you have filled up your vector with 512 things, and you only need 530, it will add 500 more places. But so maybe you should sort of keep that in mind.
Yeah, what you can do
double your memory usage, basically.
Yeah, you can do a reserve. So you can say like vector.reserve, and then you can say how much memory, or not how much memory, how many items it should sort of allocate capacity for. And reserve and resize is not the same thing, because resize will actually create the elements, but reserve will just allocate the memory. So, you know, if you do resize, all the elements will get its constructors run. So if you say resize to 500 elements, you'll run 500 constructors, etc., and assign 500 values, which, you know, it might be what you want, but it might also not. If you just say, you know, reserve, then it won't run any constructors or anything on, you just say like allocate that memory. So you can still do like pushback, etc. Like the size won't change after you do reserves. Yes. So is there any last questions before? So does everyone consider this helpful?
Can you go to the next slide again?
Definitely.
Definitely. Also, I'm unsure if I should sort of come back once during the semester to talk about architecture or anything.
I think it's brilliant if you have the time. So it'd be, I think, really good that we have a rebound, and perhaps people have new experiences that we can build up on.
Also, most of you guys obviously know me, so, and also for the rest who don't, just like if you get into trouble, especially with the C++ stuff, then just send me a message, and if I have the time, I'll look at it. However, I won't be able to help you with like the matrix calculations, etc., because I'm not that great at that stuff. But for the C++ stuff, that's, you know, yeah.
Do you have an easy way to learn CMake?
Google.
Because
Google hack and hope for the best.
Or it always looks like black magic when I open a CMake file.
Yeah, but
I try to read it, but
that's because it is black magic. Like I have a project that I'm writing in C and I'm using CMake as to build stuff.
Yeah.
And for each time I'm looking back into that you know project, I sort of go like, okay, what is going on?
So you know how to write, but you don't understand.
I know what to Google.
Okay. So basically, just when you make CMake, make one line at a time, and hope that the whole just pulls together.
Yeah. Also, by the way, about that, writing one line at a time. If you guys start looking into the like algorithms library, etc., please actually read the documentation. Don't just until it's like it's named this, so obviously it does that. There might be more to it than that, especially with a language as C++. So there might be a lot of stuff. For instance, the one I did with the vector, where I did a remove if and erase. Like if you do that wrong, that's technically undefined behavior, which means that your program is actually allowed to do whatever the fuck it wants, because that's how C++ works. Yeah. Awesome. So no more questions or comments? No?
Sounds good. Thank you very much. So it was a really good talk. So I think once the questions pile up eventually, we can either ask you or invite you for yet another session. So, but cool. So I think I didn't promise too little. That probably was the most important session as of now in the entire course. So, but because in the end, one of the objectives of the course is not only to learn about OpenGL, but also to refine your C++ skills, right? Because you can carry those over in your further years, whether or not you're actually developing your own, game engine or whatever else, or if you're just using existing ones, which is probably more likely realistically, right? Yeah. So, cool. Well, thank you very much. Yes. So, shall we thank the speaker?
Yeah.